Hello, hello. How's it going?
Hey there.
How have you been?
Hey there.
Yeah, I was asking how you been with the studies and such.
It's okay. It's been all right. Got my
Cool.
first personal stash. Kind of got amazed.
Oh, sure. Fair enough. Fair enough. Because it's 2 weeks worth of Head Start stuff.
3 days.
Oh, right. That's yeah. Yeah, you said that last time. 3 days. Cool. Okay. Um, is there anything in particular you want to have a look at today, or just continue on with the probability stuff?
Probably just continue on with the probability stuff.
Sure. Okay. So the next topic in the order is continuous probability. So a lot of what we've been doing before was the discrete side of stuff.
Yeah.
Um, when it comes to continuous, what you're looking at now is quantities which don't fit very specific values. Like for instance, a dice roll, you can only get 1 to 6 on a six-sided die. For continuous, if you're measuring something like a length, or pretty much anything that you measure, usually can be measured to some arbitrary level of precision, however many decimal places you are able to go, purely dependent on what you're measuring with, right? So pretty much just things that can be measured is usually considered continuous. The very typical examples will be like lengths, weights, times, volume, area. Any of the things that have like a unit attached to it is very typically going to be a continuous quantity. The way we handle that is with these so-called probability density functions, which basically means we're using some f of x to plot the probability curve of that particular scenario. The way it works is the area under that curve is the probability for that scenario. So if you were
Yeah.
to integrate from entirely, like from start to finish, you would get an area of 1, because that would correspond to a probability of 1. Whereas if you want to restrict that domain, what you're essentially doing is finding the probability that your quantity is between some upper or some lower, and that'll give you obviously a different probability than 1.
I've
Um,
been waiting for this because I remember doing this in exams and being like, oh, what the hell?
sure. Yeah. Pretty much as soon as you see a function f of x and it's in the probability section, it's going to be this thing. Exactly. Usually it's written as a piecewise, even if the other set of the piecewise is literally just to say 0 everywhere else. Um, but yeah, so you very typically see a piecewise here. One of the very common questions is to prove that your function is, in fact, a probability density function. Fundamentally, all you're ever doing there is using the fact that the integral should equal 1. The total probability in your given scenario must always add up to 1. And so if we're proving that our function is a PDF, that's the main criteria you're looking for. Technically, there's also a second criteria. You want to make sure your function is entirely above the x-axis, because if it ever dips below the x-axis, you start getting into negative area and therefore negative probability. This has never been an issue to look out for, but it is a technical criteria of the probability density function. Um, if you're doing this tech free, you're going to want to have a rough sketch of what you're looking at, just to make sure that f of x. And so we pause. Oh, the last one too. 5 minutes in, roughly. Come back. Did it cut off as I was explaining example one?
Yeah, basically.
Yeah. Okay.
I figured
Um,
out why it happens there now.
oh, yeah.
I have an idea what happens. It's kind of out of my control though. I think it's because before like I used to have my internet used to be 100 megabytes per second at home.
Mm,
And I think there was some sort of like rollout through MBN where like anyone with 100 megabyte per second plan, they got automatically upgraded to 500. It happened like a few months ago. Not
Hmm.
a few weeks ago, it got rolled out from like where I live, and it's
Yeah.
like this. You pay the same to like your provider, but they give you 500 MB per second. And ever since then, I don't know, it's been like really spotty. Sometimes you get five, sometimes you get 30, but even when you're doing five, when you're getting like 500, it feels like like the internet isn't as good as anymore or something like that.
Yeah, there's going to be a bit of a play between your upload and download speeds, depending on like for video call you want both, right?
Yeah.
Because you need to be able to project your stuff as well. Um,
Upload speed's been the same. It's just I think the download speed got better.
yeah, okay. Usually it's supposed to be more or less the same no matter what plan you pick. Um, upload has a bit of a cap on it. Um, but okay, interesting. So it only happened around then. Been a bit spotty. I mean, it will be spotty. Do you know how many people are using your internet?
At the moment, probably like two. Like actively using probably like two right now. But
Yeah. I mean, unless anyone's streaming like 4K videos or stuff like that, that's when you'll start to get dips in your internet just from usage.
yeah,
There's going to be other factors involved, like weather conditions potentially as well,
yeah,
messing
I
with
don't
the
know.
signal.
Like back when it was 100, it used to be totally fine. I don't know just what's
Mm.
happened. It's been like spotty, but it's yeah.
Mm.
Anyways,
Strange. Anyway, okay. So the key things you're looking for here, um, the one that's going to matter the most is that you want the total area under the function to be 1. If you're proving you have a probability density function, this is a criteria of the probability density function. There's another criteria. It's less important, but still definitely required. The reason I say it's less important is because I've never seen this one be the issue. And that is simply that you want the function to be above the x-axis, because as soon as it goes below the x-axis, integrating over that domain now becomes negative area, which you don't want, because that would
yeah.
imply negative probability. Tech-free, you might want to get a picture of this, of your function, whatever it is. Again, it's very, very unlikely this is going to be an issue, so usually you can just assume it's entirely above and then go off of that. But just in case, you might want to get a picture going. Depends on how paranoid you want to be in the real deal. A SAC might do it because they have limited scope, but never
But then
seen it.
how would that like work? Would it just be the positive part of the function adds up to one, or like?
No, so as soon as it dips below, it's already invalid, no longer a
Okay.
PDF. So as this said 7, like let's assume, I don't know, if we cut this to like 1 to 7 and we assume that that's still, no, it wouldn't add up to 1. Point is, even if you do get like the thing adding up to 1, as soon as it dips below, bad. Because that would imply you've got some negative probability in the
Yeah.
scenario. Proving it, this is just the definite integral, antidiff, sub n top and bottom with the subtraction between them. And yeah, you get 1 as your result. This would be the final line that you keep. The integral from 0 to 6 is equal to 1. That would be your final working out line, and then you'd have some sort of hence or therefore function is a PDF. You're allowed to use that acronym there because writing out probability density function is a lot. A slight permutation of that, sometimes they'll chuck a k in there. It could be in the function or it could be in the domain. Domain is definitely going to be a CAS thing to solve. If it's in the function, that's more common to be tech-free than otherwise. It's still the exact same procedure though. You just want to make the thing equal to 1 and then solve from there. Nothing else to really talk about besides maybe this one here when you're working with circular functions and the stuff is in the domain, because you're chucking k's in a circular function, you start running into issues of infinite solutions. So you just want to put in either the domain that's given to you there, or no, I guess it would have to be given to you. You couldn't really just assume anything else. Because I know there is one somewhere else, maybe not in here. Yeah, like in here, for instance, you can't necessarily just assume the first period because it might be further along. But okay, that's those. this one here, we're just looking at actually using a probability density function, specifically in this case to find the probability for a given domain of outcomes, 2 to 4, and so fundamentally we're just going to use those as our integral bounds, and then solve pretty much the same as before, but this time we don't know that it equals 1. I guess we do know that it does not equal 1, and we have to figure out what it's going to be. The outcome of the integral being the probability. These are kind of common, so these are referred to as, yeah, they go by a few names. I've just said pretty simply we're finding a lower bound or an upper bound of an interval. Fundamentally, all we're doing is putting a coefficient as either the top or bottom, depending on what direction the inequality is facing. X being greater than A means we're looking at all values that are greater than A, which means we're going to cap out at our upper bound, and A is going to be the lower bound. If the inequality is reversed, you're going below. So A is the upper, and then 9 pi would be your lower. Once again, solve as you do for solving definite integrals. If you have circular functions, it can get a bit involved, because once you get it down to its simplest form, you've now got to solve using the methods we know for solving circular functions. You're doing the sine inverse of root 2 on 2 and then rearranging to get the A on its own. And in this particular example, because I made it such that it had a bit of a weirder domain, you actually now have to go and find additional... you can do a general solution like I've done here, or you can just add 2 pi a bunch of times until you get there. It's fundamentally the exact same thing. You do still need to get to the only A value that actually fits within the domain. Whether you choose to write your own method using these ends or otherwise is up to you. Yeah, that's that one. Conditional probability works the same as it always has. You want to find the intersection of the two things and divide by the probability of the conditional. So in this case, it's from 2 to 3 given it's less than 4. You're effectively just solving two separate integrals now. If you ever need help identifying what the actual intersection is, just plot the two things on a number line and then just look at where they overlap. Once you do this a couple of times, you pretty much will quickly realize you don't really need this picture anymore. You'll be able to spot them relatively quickly. And then yeah, this is a lot. You're just solving numerator, denominator individually, and then performing the division as per the probability or the conditional probability formula. Those are the probability aspects of PDFs. How's all that so far?
Sounding good.
Do you want to move on to statistics or practice a few of the probability stuff?
Probably practice.
Let's do it. Continuous. Cool. Nice and simple. Question 1. Prove that this function is a PDF, probability density function.
Is it because the integral of 24 on x to the power 3 over 3 to 6 is equal to 1?
Sure is. Yeah. So you got your integral to equal 1?
Yeah, yeah, I did.
Easy. Nice
I
work.
got I got like capital F of x as negative 12 over x squared and then just sub in the numbers.
Yeah, precisely.
But just to clarify, because it's been a long time, when you do these types of integrals, do you like to put the x to the power 3 like up and put it into negative indices and then use the power rule or
I mean, that's technically what's happening. It's purely, I'm not fussed how you do it. That's how I do it, which is using negative index, but whatever works for you consistently, you should do. I think a lot of
how do
people
you
would
would
prefer
there be
negative indexes. Hey,
yeah, cool.
yeah. A lot of people probably prefer negative indexes simply because that's how it looks in the integral on your formula sheet. And that way you can just
Yeah,
say, oh, n is negative whatever, and then go from there.
cool.
Yeah, that's question one. Question two is kind of similar. Three has a probability thing in it, although I have spotted question four, which kind of does both back to back. So I think that might be a good start to get in there. So find K. K is right there. And yeah, that's pretty much all the information. I guess it's worth pointing out the fact that this is a probability density function is in and of itself information. It's a little bit less obvious that it's key information, but yeah.
I think I know where we're going here.
Okay.
Just take k outside of the integral, I'm pretty sure.
Yeah, you can take K out to start with. Works fine. That's probably better to take it out rather than leave it in.
Yo. Okay.
Mhm.
This is a little bit confusing. I'm gonna try my best. Because I'm guessing that when you want to prove with an integral, is your upper bound going to be infinity? Because there's a constriction.
Yeah, precisely.
But
So
then
it
if
will
I
be
were to sub
infinity.
infinity into an exponential, it's going to keep on going.
Uh, yeah. So you're not going to get a specific value. You're not going to get like um, the integral. How to say it? It'll be a limit. Is what I'm trying to get at. It'll approach a specific value. So just think of infinity as like what happens as the power, the negative index or otherwise, if you flipped it, gets bigger.
For
Try to think of
this,
it that way.
it's also going to approach infinity,
Um,
I think.
what would you have as a capital F?
I had a negative e to the negative.
Mm-hmm.
Approach negative infinity.
Well, no. The power is negative infinity. Having a negative index does not make a negative number. Um, Try flip to positive index. Have it as a fraction. So rather than minus e minus y or minus infinity, you have negative 1 over e to the y.
So it's gonna be like almost zero.
0. Yeah, precisely. It'll shoot towards its asymptote. You've got a massive denominator, effectively 0. So that
So
term cancels
k
out.
is equal to negative one.
K is equal to, should be positive 1.
Yo, what?
Because you do capital F of infinity minus capital F of 0, and then two minuses, and that back end become a plus.
But so you see how like the lower bound of the integral is zero,
Yeah,
and I got negative e to the negative y as my integral, or otherwise negative one on e to the y.
yeah, yeah.
When you put in zero, shouldn't that become negative one? Oh,
Yes, but there's a minus.
yep, I get you. Okay, I got it the wrong way around. I
No,
did
you
the
good.
e one first.
Oh, you did. Okay, you did the 0
Yeah.
and then
Should
infinity.
have should have done infinity first.
Yeah, correct. All good. Yeah, you're allowed to just sort of write 0 immediately in there. The book answers have done something where they've chucked limits in there, so that's the more technically correct way, although I've literally never seen it be required to put in limits for those sorts of things.
Yeah.
Like, let's see, what's this? 15a, question 4. This is what the book's written, which is, geez, okay. They've chucked in a limit as their thing first, then done the antidiff using the I don't really know what notation this is called, but it's the alternative notation, and then just sort of kept the limit the whole way through. Which, I mean, if you want to use that, you can, but I feel like that's excessive.
Yeah, makes sense.
All right, so that's finding the k. The follow-up there is now that we have the k, we can find our probability of y being less than or equal to 2.
Yeah. Probability of y being less than or equal to 2.
Mhm.
Isn't that 1?
I can guarantee it's not going to be 1.
Wait, less than or equal to 2 doesn't. But isn't the probability always going to be less than 1?
Yep, it's going to be less than 1, so it should never equal 1.
All right.
Um,
No, but so wouldn't it always be less than 2?
uh, so y is the outcome, the x-axis. So the reason they made it a bit weird, they've used y's instead of x's here.
Oh,
Um, this is effectively the x-axis, so the results on the bottom have to be all less than or equal to 2.
got you. Can I give it an exact form?
Yeah, yeah, exact.
Negative 1 on e squared.
Negative 1 on e squared is one of the terms. There should be another term in there, plus 1. You should have an e to the 0.
No, I don't. Oh yeah, I see.
Oh, okay.
-1.
Plus, because it's double negative again.
Oh, yep. Sorry about that.
No, you can. That's how we practice. Yeah. So this is all just doing definite integrals, same as usual. Cool. So whenever trying to find probabilities, it's definite integrals. Whenever you're trying to find coefficients, that's also going to be definite integrals. In fact, wasn't the whole thing? Wasn't there something that wasn't? No? Okay. So it's pretty much always definite integrals. It's just whether they equal something ahead of time or not. Coefficients, it equals something. Probability, you're actually trying to find the result of the definite integral. And then question 5 is less straightforward. They haven't just given you just basic information in the way that you expect. It's now got a bit of a background to it for you to try and interpret and then calculate off of that.
Quarantine period for skin disease is
Don't
between
worry about the
5.
sketch unless you want to.
No, it's just a quadratic.
It is just a quadratic, yeah.
It's gonna be a positive quadratic and pretty wide. Oh, oopsie daisies, spoke too soon.
Yeah.
Negative quadratic, but
Yeah.
very wide quadratic.
Yeah, fairly wide. It'll cut at 5 and 11. And then because of that dilation factor, yeah, it'll make it very close to the x-axis.
Probability of showing the first symptoms at various times during the probability density function. All right. Appear within 7 days. Cool. I think I can sort of understand what the question like what trick the question tries to play.
Oh yeah.
It's because you got to look at like when it's above the x-axis.
Um. Yeah. Yeah. When it's above the x-axis is correct. There's a couple of so there is the fact that yeah, because of probability being positive rather than negative. There's another piece of information that means you don't necessarily have to worry about that, even though it is something that should be considered. And that's because I actually tell you
Yeah, 5 and 11
this bit
days
here.
restriction.
Yeah, yeah. But no, good looking out. The arithmetic will get a bit heavy here. If you want to use a CAS to speed things along, you can.
Really?
It's heavy-ish. Because that fraction 1 over 36 will be a bit of a pain.
Oh, yeah, true.
Up to you.
I'll probably I'll probably define my integral as a function and sub in the thing.
Yeah, sure. And then for the conditional probability afterwards, you definitely want it.
My question is, why do they have like so many like questions throughout the textbook where like the arithmetic is so heavy, but they don't want us to use CAS.
I think it's less that they don't want you to use CAS and more that they just keep forgetting to put in whether it's a CAS thing or not. Because they give in this one they actually said approximate decimal answers. In fact, part C has no no exact answer. It's a decimal, and you're not going to get that by hand. So
Yeah,
they
I
just
got
stop
the
bothering.
yeah, okay, fair enough. Hey, I got the thing.
Yeah,
Fraction 7/27, so
that's it.
approximately 0.26.
Yeah, 7/27. That one did have a fraction. The next two don't.
All right.
But yeah,
Fine.
good. So that
Simple.
was post you figuring out the antidiff by hand.
Yes, that's
Nice,
correct.
very
Well,
good.
now that'll help me anyways, knowing the antidiff.
Hmm. Yeah.
4.5 days. My public system seems 23 on 96, which is 0.24.
2, 4. Yeah, that's good. Nice. So top one was from 5.5 to 7, and the other was 5.5 to 11. Yeah, I think that's how they should have looked. These basically the same thing.
Yeah, I'll just it's okay, fine. It's just 5 to 7 over 5 to 10.
5 to 7 over 5 to.
Like
Oh, this one. Yeah, you're talking about this
yeah,
one.
okay.
Yeah. Okay, cool. Okay, let's see. Is there anything different here? Show that k greater than that, between that. Yeah, that's just sort of whatever. So again, basically, whenever they're talking about quantities, those are your domain, your x values, or if they want to be cheeky with it, whatever the coefficient is for the f of blank. Find k, find probability of more than something, get k between. Yeah, that's all the key questions there. Maybe I'll scroll
Cool.
to the end and see if there's anything in there you want to take a stab at. Otherwise, we've done all the key things.
Piecewise. Three-way piecewise as well.
Yeah, that's a bit cheekier. Um,
Find the
remember how
probability
to.
that x is less than or equal to 0.5.
Yep.
Okay. Just to confirm, right? Does piecewise mean that the total thing, like the total, if we integrated the total graph, it would be 1?
Yeah, has to add up to 1 for the full integral, otherwise it couldn't be a probability density function. Yep.
Okay, cool.
That actually is a good thing to point out, because it means you don't have to solve two separate integrals. You can actually just sort of do 1 minus something. That's good. No, you still need two separate, don't you? No, you can do it in one.
Um, 1 on 4?
Oh, right. Let me have a look. 14. B. Hang on, was this? Which one did we do? 14A. 14A should have came out to 9 on 20.
Oh, hold on. Okay,
So, yeah.
let me see what I did wrong. See 9 on 20?
9 on 20, yeah. Did you. What was your approach?
You see the middle function?
Yep.
Because that was between the domains of 0 and 1, and we're trying to find it less. Never mind. Give me a second.
Yeah, I think you started it.
Yeah. All right. Yeah, 9 and 20.
No, not 20. Yeah.
1 on 4 plus 1 on 5.
So I'm assuming based off that you did 0 to 0.5 for this one, -1 to 0 for that one, and then added them.
Yes.
Yeah. That's fine. I did just sort of hypothetically think there was also, you could do 0.5 to 1 here, and then using the thing you said at the beginning, you could do 1 minus that, and that means you're only doing one integral. Granted, this is a pretty simple thing. This is in fact just a rectangle, fundamentally. But if it was any more complicated, you might consider doing the complement probability thing.
Yeah, makes sense.
There's a conditional here if you want it, but it's still just the same sort of idea if you want
Yeah,
to.
it's alright. No worries. We're going.
Okay, statistics. Cool. So a lot of them are going to be the same. There is going to be technically one or two, yeah, maybe two new things we'll have a look at here, at least as far as statistics go. All of them are going to be calculated differently because we're using integrals. But yeah, for mean, we're simply just doing the integral of x times f of x. So whatever your f of x is, you're just slapping a multiplication of x on that function and then integrating over the full domain. And that gives you mean. Fairly straightforward. We got truncus here. When you multiply a truncus by x, you now get back to a hyperbola, and then the antidiff of that is a log. So, yeah, I don't know. This whole sequence here has always been strange to remember. Definitely always looking at the formula sheet for that one. Super rare, just like when we looked at it previously. If for whatever reason you have to do e of something other than just x, for instance e of ax plus b, you can do a simplification in here, although it's so rare I wouldn't really bother remembering it. The only one to bother with would be the less variance. No, I don't actually do it here. Interesting. I was going to say for variance, you know how you do like the e of x squared minus e of x all squared.
Yeah.
It's the same thing where basically instead of multiplying by x, the function, you're multiplying by whatever's in the brackets here. So for the 2x plus 3, it's 2x plus 3. For the x squared, it would be x squared. Although in this method, I've actually used, I think this is the one that goes on the formula sheet. And this is okay because these are always CAS, so I'm not too bothered by using this full, which would be a lot more painful by hand, this version of the formula. You still want to find the mean, as before, using the previous method, and then you just chuck that result in that spot. You would never do them in the same line. That would be awful. You'd have the integral and then an integral sign in this spot right here. So definitely
What
do
would you
those.
recommend still? Like you personally?
What would I recommend? Is that the question?
Like you know how so there's like the x minus mean squared
Yeah.
times f of x. Would you rather do that, or would you rather do find mean like find mean using x squared?
For this, I would do this because it's CAS. You're still going to do two separate things and smack them together anyway. And so I figure just find the mean, and then whatever the result is, you just grab a copy of it and chuck it there. Control C, Control V. This is what I would do for this in particular. Anytime you're doing it by hand, you would never do any of these by hand, by the way. But any like discrete stuff, yeah, it's only discrete that you would ever do by hand. That's when you do the e of x squared minus e of x whole squared.
Yeah.
But yeah, precisely that. Again, there's simplifications. I put it because it's in the book. You're never going to do it. Standard deviation is always the square root of variance, so whatever method you decide works best for you, just put a square root on the end of it and you're happy. Oh, right, I skipped over median. So this is the new one that gets introduced in continuous. Well, new as far as methods is concerned anyway. General does a fair bit of this sort of stuff. So median is referred to, it's a special kind of percentile. And what a percentile is, you've probably already come across it, it's simply just a percentage of the total results. So for instance, the 70th percentile just means over what domain accounts for 70% of the total results or total probability. So effectively all we're ever doing is solving for an upper bound. It always starts from left and goes up to some upper bound of the result. And depending on what percentile you're trying to solve for will be what you equal the integral to.
And I'm guessing is median like equal to 0.5? Yeah.
Median's equal to 0.5. Yeah. Median, dead center of the data set. Referred to as the 50th percentile sometimes, although I'd be shocked if you ever hear that. Its name, you would only ever use like the word percentile for things that are not the 50%. They don't really word like a percentile. Like they don't use the word percentile usually. Like a typical way of framing that question would be to say something to the effect of, find the value of A such that 90% of phone calls last less than A minutes. We've done this before. Anytime you're solving an inequality, we're solving a percentile like this. This is a percentile question. It's pointing the wrong way. It's pointing upwards instead of downwards, but it's the exact same idea, which is the thing that you're given. You're given a target probability. You're given a target probability. You're less than A minutes. This was greater than A whatever the unit was. Same procedure. Yeah, just referred to as a statistic this time. I guess they didn't really say statistics in here, so I guess this is technically another entry for solving probability stuff, but yeah, that's the crossover. Pretty much everything in the statistic stuff is going to be TEC active, and the reason why is because you're pretty much always multiplying your function by x, and if your function is not some kind of polynomial, or yeah, these don't count as polynomials. I think we had this conversation earlier, which is even though it's x to the power of something, it caps out at 0. I don't really know what this this family is called.
Isn't this just a truncus?
Yeah, I know it's a truncus, yeah, but like as you increase the power, you go from truncus to hyperbola to truncus to hyperbola. I don't know what the generic name for it is. I'm sure it's something.
Negative polynomial.
Yeah, maybe a negative polynomial, something like that. But yeah, that's the reason it's usually TEC active, because multiplying any non-polynomial by x, you've suddenly got an integral where you're doing, well, in fact, there might have been a question, because you know how you have like your x natural log x as the integral or something like that, and they get you to do integration by recognition.
Yes.
think I've seen a probability-based version of that, which fundamentally is literally no different, because you're still just solving an integral at the end of the day. It's literally the exact same procedure, word for word, line for line, but as soon as you put the word probability at the start, people then reframe it as a different question and get a bit confused.
Almost like people who write maths questions are also psychologists.
Yeah, there's just a bit of that going on where it's like, how can I make this look as intimidating as possible? What kind of deep psychological historic fears can I put into the students? Oh dear. Yeah, I reckon there's going to be a bit of that going on. That's where the separator questions are going to come from. Those little 1 markers, where they just kind of make it look as weird as possible. But fundamentally, it's an easy enough question once you get it. The one that always comes to mind is the probability question with the coin flip, where they measured the distance of the coin from table to coin height. Well, I guess it was floor to coin height, and there was a transformation on it that changed it from being floor to coin versus ceiling to coin. And once you understood the flip, the coefficients of the probability made a lot of sense once you saw them. But actually trying to figure that out under time conditions, not great.
Yeah.
Do you remember
Just
roughly the question?
honestly, it probably would have like because back when like we used to get probability questions, right? I used to
Yeah.
like try to focus on the first like what like 2 minutes, and then after that, like I couldn't even understand half the
Oh
jargon,
no.
and I was like, oh
Damn, you should have raised your hand next time. I'm more than happy to dive deeper into those questions. It's like people are going to have the same question as
but
you. Because if
it
you were
wouldn't
falling
it would
behind, yeah.
it wouldn't help because I didn't even like know what it was like at
Hmm.
all. Probably wise, so
Yeah, okay, sure. Oh well, we're fixing that now, I suppose.
yeah.
Okay, so interquartile range is less. It is a statistic. Yeah, I'm not gonna downplay what it is. The reason why I'm sort of downplaying it a little bit is because you're just solving percentiles. So you're just solving the 25th and 75th percentile, and then just sticking a subtraction between them. That's what IQR interquartile range is. Yeah, so no real new math except for the fact that you're putting a subtraction between two percentiles. And there's the big summary sheet. You got your mean, you got your median slash percentile stuff, variance, standard deviation, and interquartile range. The new ones, of course, being the median and the application of it, which is the interquartile range. Anything in there worth diving deeper into? So, oh, hang on. Now there's two of you in the chat. You back in?
Yes, I'm back.
Yeah, okay, cool. Did you cut out before finishing the interquartile range?
You were sort of just talking about why you sort of downplay IQ.
Oh, yeah. Simply because it's just doing two separate percentiles and then putting a subtraction between them. It is its own statistic, yes, but fundamentally you're not doing anything different. You're just solving two of them and then just subtracting. That's all. Cool.
Yeah.
Awesome. All right. The book splits that up between 15B and 15C. Mean and percentiles go in 15B, and the variance standard deviation stuff, measures of spread, possibly even IQR might go in here. Yeah, well, had a feeling because you're doing a horizontal distance, makes sense for that to be in spread. Let's see, we've got about 10 minutes, so maybe, yeah, they're all basically. Well, was there anything in it that seemed like it was more complicated than anything else?
Not really, but
Yeah, okay.
I guess we'll have a look.
We'll do some key ones then. Um, Basics of finding the mean, so E of x. Yeah, take your pick. Anything from question 1, even question 2.
Always do 2C. Looks pretty involved.
Yeah,
It's
sure.
calculator though.
It is, yeah, it is calculator. You're not going to do, this isn't going to appear on your formula sheet.
Use the form, use a calculator, check that F is probability of C function. Okay, boom. Okay, so it is a probability density function. I can tell you that.
Yep.
And let me just copy that over. And like the mean is 1.13.
Yeah, 1.13. Cool. Okay, that's mean. There's a slight weirdly worded question here. Question 3b. Find the probability that x is less than or equal to the mean. It's like a half trick, if anything. Um,
Take value less than or equal to the mean. Okay, I'll try and find the mean first.
yeah, that's precisely it. You'd find the mean and then, yeah, go from there.
Two x to the power of 4 minus x squared plus x. 17 on 30.
17 on 30. Yep. And then for x being less than or equal to the mean,
Um, less than or equal to the mean. I want to say it's 17 on 30, but I don't know if that's true.
so 17 on 30, what you just solved. The mean is the center of the yeah, it's the weighted average of the data set. And so yes, it's the results. How to put it? Um, when we did mean with the probability tables, you're basically finding where most of the probability is centered. You've essentially found an x value, not a probability. The mean is an x value. It exists on the domain rather than as a probability.
Okay, let me try something.
Mhm.
Is it 12%?
12% is a little small.
Oh, wait, weighted average. Does that mean it's going to be 50%?
Yeah, see, that's the challenge, which is I was trying to word it in a way where it doesn't imply 50% because that's median. Median is the 50% mark. Um, the yeah, kind of hard to visualize exactly the context of mean there. Um, it's the most likely result. It doesn't mean, yeah, how do I word it? It's not 50%. Point is what you're thinking of is median. Mean is a slightly different take on it. It'll be close to 50, but it's not going to be exactly 50 unless you have a bell curve. Unless it's a perfectly symmetrical bell curve, it's not going to be 50-50. What you're doing here is essentially for x being less than or equal to the mean, if the mean is just an x value, then it's kind of like just saying x is less than or equal to some number, which in this case is 17 over 30. So effectively, this is just saying 17 on 30 is your upper and 0 is your lower, simply because you've got to cap out at 0 on this one.
Oh, wait, you know what I think I've done?
Hmm.
Wait, I'm gonna try have one more stab at this, and
Yep.
then you can tell me if I'm wrong. 0.46, so 46%.
Yeah. Yeah. 0.46 is better.
Okay. So you know what I was doing is I was putting
Hmm.
first I put 17 on 30 into the like x times f of x function.
Oh. Oh, yes. Yes. That's,
Yeah.
yeah, I probably should have mentioned that actually. That's a very common thing that people will do because it's the very first thing you do usually. Or at least at some point in the scenario you have that and you forget that
It's
you
just so
multiply
easy
by
to
x.
copy. You're just so used to copy
Yeah,
pasting.
yeah.
Yeah.
That's a super common thing to fall into.
One thing I'm learning is there's a lot of metacognition in like probability.
Yeah. There's a few little pitfalls you can fall into. But yeah, I mean, as soon as you understand those pitfalls and avoid them, just know that everyone before you has to also overcome those things. I think that's my
Yes.
favorite way of reframing hard things. Where it's like, cool, oh yeah, that was really hard. Good luck to everyone that's got to follow me. But okay, question 4, expected value again. This is kind of interesting. This time you got the value of the mean, and you have to figure out what A and B would end up becoming. We're getting shorter on time. Would you like me to run through a few more of the key ones, just high level, or would you rather just practice this last one?
Honestly, like, could you just like run through?
Go high level. Yeah.
Yeah.
If the mean is 2, it means the integral from 0 to b must be 1. Sorry, the integral from 0 to b, well, that's a separate thing. Integral from 0 to b must be 1, and x times, or I guess in this case y times, the integral from 0 to b must be equal to 2. 2 equations, 2 unknowns, simultaneous solve.
Yes. Okay.
1 over x, e to the x, again, those just mean instead of multiplying these by x, you're multiplying them by whatever's in the bracket to the e. It's mainly a book thing. Done this, done this. This is a percentile. They even tell you it's the median. This one's, we literally practiced this last time. Just set the upper bound or lower, well, in this case it's an upper bound of m, and make the interval equal to 0.5. We've already done find k. This is a repeat, and I think there's a weird thing in here. Oh yeah, here we go. So the diff, hence find anti-diff stuff in the context of probability does show up. Is simply because the integral is tough to do otherwise.
Honestly, looking at it, it just looks like the diff of that is going to be like whatever's in the integral already, whatever's in the f of x.
Yeah. Or it's going to be very similar.
Yeah.
Sometimes you do have to do it. Well, most of the time you'll have to put a little bit of a spin on it afterwards. But we did see at least one question where it just flat out ended up being like 1-to-1 exactly right.
Because I practiced these ones because I wasn't really good at them when I started integration, like
Yeah.
the hence find or whatever.
Mhm.
And what I observed was like the harder ones, they usually just like keep it the same. It's just more like a, I guess like a step in your like thing. Like the ones that are really hard.
Yeah, interesting. Okay. But yeah, that's a very common one to get to struggle with, which is good that you're focused on practicing it. Variance, they're doing it the e of x squared minus mean squared. You can do that. That's perfectly fine. It's literally just going to be whatever you feel most comfortable with. An interquartile range. We've already seen how to use percentiles, so just do what you've just done already, and then subtract one from the other. Specifically, you go 25th into 75th. Do the subtraction between those. Bigger number minus smaller number is also the other way to think about it. Cool. That's about it. That takes you to 5C. 15C. 15D, don't. Where's the star? Yeah, don't bother with it unless you're really curious. And 15E usually gets skipped simply because it doesn't show up in exams. However, it might be a SAC thing, so watch
Yeah.
out for it if it does come up.
Cool.
That's
All right.
continuous.
Thank
Any
you.
final thoughts?
No, not really.
Easy.
Thank you for that.
Until next time.
Yep. See you.
Bye.